Okay, so this is June 25 version 3.2. Let's start doing this. I think the title has an error, but fine. Fix that later. Yeah, okay. Starting with question number 1. This is e power x plus 2 e power minus x. Let me just open up as well so that I can verify the answer. One. Okay, so the first question is an exponential question. With an exponential, what I am supposed to do is I am supposed to do a substitution and then follow it up with a quadratic. If it becomes a quadratic, you think short. Yeah. Okay. So u plus this will become 2 over u, and u minus 3 equals to 4. So u plus 2 over u equals to 4u minus 12. I have then u squared plus 2 over u equals to 4u minus 12. I've taken the substitution u equals to e power x. Okay, and then u square plus 2 equals to 4u square minus 12u. Okay, so this gives me 3u square minus 12u minus 2. So let's do this quadratic. I will need to show you the quadratic formula because there are a lot of marks on this. Okay, so on my calculator, quadratic e minus 12. I am getting u equals to 4.160 and u equals to minus 0.16. These are both values for e power x. So I will have to introduce an ln 4.16, and this one isn't possible. That's ln of 4.16, 1.43. The question says 3 decimal places, so not 1.43 but 1.426. Okay, that's question number 1. Question number 2 is about expanding and ascending powers of x up to and including the term in x squared. So I will pick this up. Now I have a formula that gets me all the terms directly. So I'm just going to mentally start applying that formula. So that's a power n. Then I have n a n minus 1 minus 2x power 1, and term number 3 is minus 3 over 2 into minus 3 over 2 minus 1 divided by 2 factorial, minus 3 over 2 minus 2 and minus 2x squared. Calculate this one is 1. That's easy. This one is minus 3x, I think, or rather plus 3x. I'll have to calculate that one. Minus 1 over 0.5 into minus 2.5 divide by 2 into 4. That's 15 over 2, and that's also a positive x squared. So I have to then multiply 6 minus x with all of this. So 1 plus 3x plus 15 over 2x squared. But multiplying, you get 6 plus 18x plus 45x squared minus x minus 3x squared. Yeah, that's it. So 6 plus 17x plus 42x squared. That should be the final answer. Simplifying the coefficient. Yeah. Take the set of values of x for which the expansion is valid. So there is this range of validity that says modulus of x is less than a over b. What is a and b? A and b are the coefficients of these two numbers here. So you get modulus of x is less than 1 over 2. Okay, you can also write this as between minus half and half. There's an entire story behind it. If you've seen the lecture videos, you would have seen the story. Okay, question number 3. On an Argand diagram, shade the region whose points represent complex numbers. Complex numbers z which satisfy both inequalities. Now this is something that I haven't taught so far in my classes, but since it's part of the yearly paper and I am recording this as well, I will solve this. Okay. Let's say I have a ruler again on my screen that is not visible to you right now. I'm going to make it visible in a bit once I plot the points that I am supposed to plot. So right, let's just make it visible. And you can see the entire screen. Okay, that's 3, so that's minus, that's 3. I wanted actually plus 3i. So plus 3. Okay. Okay, so I need a circle first with radius of 2 and the center is at this. So I'm just going to mark 2 centimeters from here so that I can draw the circle for you. Okay, so the circle has to look something like this. Okay, yeah, I need shading inside the circle, so that's also happened automatically. I didn't have to do it, but that's what I'm going to do. Okay, approximately that. I can't be exactly sure of the circle. And then I have 1 plus 2i. So 1 plus 2i, so 1 should be here. Okay, that's 1. And plus 2i. So we are talking about something in this line. So we are talking about point. So from here, there has to be a half line that's at pi over 4. and that's at 3 pi over 4. So what I want is that I want to draw a half line that begins here, and I measure this angle, go up to 45. Okay, so that angle is at 45, so there's going to be a half line that starts like that, and there's one at 135. That's 180. I want it at 135. I'm going to make approximately a 90-degree angle with this one. You see the 135, my starting point. So I want an argument between 90 and 45 and 135. Okay, and I want to stay inside the circle. So what region should I shade? I should shade, according to me, let's say is this part. Okay, what I should shade is this region. Okay, let's see if that is the correct thing to do. Yeah, that looks approximately fine. So you shade that properly and you're done. Okay, that was an Argand diagram. Let's look at now trigonometry. Okay, so 3 cot x minus 4 cot 2x. So I don't know the identities for cot x, but I certainly know tan x, and tan 2x is 2 tan x over 1 minus tan square x. So I'm going to write the reciprocal of that, equals to 3. You can cancel out with that. So I have tan x equals to tan x as the denominator, 3 minus 2 plus 2 square x equals to 3. So 2 tan square x plus 1 equals to 3 tan x, and then two tan square x minus 3 tan x plus 1 equals 0. Yeah, okay, then I can break the middle term. Actually here it's easy breaking the middle term. It's 2 and 1, so 2 tan x and tan x minus 1 minus 1 tan x minus 1. So 0 to 180, the range is also pretty small, so tan x minus 1 and 2 tan x equals to 0. So tan x is equals to 1 and tan x is equals to half. Both are going to be in quadrant 1 and 3. I can disregard 3 right now. Why? Because it's from 0 to 180. The two alphas involved, two basic angles involved, so that's 45 degrees. And tan inverse of half is 26. So quadrant 1, the answer should be 45. I can ignore quadrant 3. Quadrant 1, again, the answer should be 26.6 degrees. Okay, then we have question number 5. This is again something on complex numbers. Let's just do that because I want to record the entire paper. The square roots of this can be expressed in the Cartesian form this. Okay, by first forming a quartic equation in x and y. Quartic is pi over 4. Find the square roots of this in exact Cartesian coordinates. Okay, so I'm going to square both sides and say that then I have something comparable. X squared plus 2xyi plus y squared I squared. I have x squared minus y squared plus 2xyi. So x squared minus y squared should equal minus 1, and minus 4 root 5 should equal to xy. Okay, I have to take some sort of substitution. So I'm going to take a substitution for y. So y is minus 2 root 5 over x. Minus 2 root 5 over x squared equals to minus 1. So x squared minus, that's 4 into 5, 20 over x squared equals minus 1. Okay, that's the quartic equation in x or y. That's quartic equation in x. Okay, that's basically a disguised quadratic equation. Okay, this is something that you do in AS. You can break up the middle term again. I see very clear cut numbers. Oh, x squared plus 5 minus 4x squared plus 5 equals to 0. I have x squared plus 5 and x squared minus 4 equals to 0. Okay, are x and y real numbers? Where x and y are real. So this can't be possible because x squared is negative 5, so not real. X squared minus 4 equals to 0. X can either be 2 or minus 2. If x is 2 or minus 2, then y can be minus 2 root 5 over x, which is 2. So that's minus root 5 or plus root 5. So I have 2 minus root 5i or minus 2 plus root 5i. I think those should be the correct answers. Let me just verify from my calculations. So 2 minus root 5 and my... Yep, those are the two correct answers for this question. Question number 6 says, by sketching a suitable pair of graphs, show that the equation this has only one root in the interval. So I have to draw the graph of sine half x. Okay. So 90 basically pi over 2 and pi. Okay, that's 1, that's 2, let's say. So the graph of sine 2 sine half x should be at 2 and when it's at pi, and it should be at 0 when it's at 0. So that's the graph of 2 sine x. When you have modulus of x minus 2, to break it up into two parts, x minus 2 and minus x plus 2, y equals to x minus 2 and y equals plus 2. The minus 2 is here, and intercept should be pi minus 2 is about 1.142. So this line should go from about, let's draw that in green, here to here. Okay, and the other one should be from here to here, I think. Okay, so that's the graph of modulus x minus 2. And there are various ways to draw the graph of modulus functions, whichever way you've learned. As long as you can draw it correctly, that should be fine. With question number 6, it says, show by calculation that this root lies between 1 and 1.5. So you bring everything to one side and you create a function first, and you say modulus of x minus 2 minus 2 sine half x. Then you plug in f of 1. Okay, so I go with f of 1. So that's 1 minus, my calculator is in degrees. 1 minus 2 sine 0.5. That's 0.0411. Okay, and the other one has to be 0.5 is 0.5 and 0.7. So minus 0.863. Change of sign indicates root. Okay, then it says use the iterative formula this with an initial value of 1.03. So 1.03. Okay, let's take out x2. So 1.03 is programmed into my calculator, and then I use 2 sine 0.5 into answer. So the next iteration is 1.0149, 1.01, 1.0281, 1.03, 1.0166, 0.02, 1.0266, 1.03. Like, have I done something wrong, or let's see, 1.017902. Let me check why this keeps fluctuating. Okay, now it's boiled down to 1.02. Okay, yeah, I needed all those iterations to prove that. Very weird in that way. Usually you don't have questions that fluctuate so closely, but this one did. Okay, moving on. This is express 7 sine theta plus 24 cos theta in the form on cos theta minus alpha. Now, if you do it with harmonic identities, you should remember that whatever is here should be in the first place. So this needs to be rearranged. I've never seen that in the past papers, but it's there. So you need to know that now. Okay, so r is basically root of 24 squared plus 7 squared. That's, I think, 25. Alpha is then tan inverse of 7 over 24, not 24 over 7. Okay, what's 7 over 24? 0.284. 0.28. Okay. So I've expressed this, and that should give me all the marks that I want. This is 4 decimal places, so 2838 mistake. Okay, moving on. This is hence solve this equation. So this is pretty much the same equation. So I can just write around 25 cos. Instead of theta, I have 1/3 x minus 2.838 equals to 24.5 cos of 1/3 x. Okay, then let's move on to quadrants. Quadrant 1 and quadrant 4. The basic angle is going to be this time cos inverse of 24.5 over 25. That's a very small angle. 0.2. The quadrant 1, 1/3 x equals to 0.2. Quadrant 4, 1/3 x 2 pi minus 0.2. Let's calculate 0.2 plus 0.2838 into 3. It gives me 1.45. So 0 to pi, so less than 3.142. That sounds like the correct answer. Look at this one. 838 2. It's 19.1 that has to be discarded. But whenever you now discard something, so you have to bring something in that position. What would I have? I would have the negative quadrant 1 in this position. So how will I calculate the negative quadrant 1? That's simply negative alpha. Okay, so negative 0.2. So negative 0.2 plus 0.2838 to 3. I'm getting x is 0.251. Okay, yeah, I think those are the two correct answers. One is this and the other one is that. In question number 8, the variables x and theta satisfy the differential equation this. When x equals to 0, and x equals to 0 and theta equals to pi over 12, solve the differential equation and obtain an expression for x in terms of theta. So 1 over 4x plus 3 dx is cos 2 theta or sine 2 theta. This is called separation of variables. You separate the variables so that they follow x on one side and theta on the other side. This becomes ln 4x plus 3 equals to, this is basically cot 2 theta, and you should remember the integration of cot 2 theta, that's ln sine 2 theta over 2. You come up with integration by recognition. That's something that you need to remember, that cot theta is basically integrated, and integrated cot theta becomes ln sine theta. Okay, so in this case, ln sine 2 theta divided by 2, and you have a plus c, ln 4x plus 3. Okay, when x is 0 and theta is pi over 12, so x is 0, so that gives me ln 3, ln sine 2 pi over 12 over 2, 3. That gives me ln half over 2 plus c. Ln half is basically ln 1 minus ln 2, so that's minus ln 2 over 2 plus c. Ln 3. Ln 3 plus ln 2 over 2 equals to c. I want to make x the subject of the equation, so I will have to plug in x, c back and see what I get. So ln sine 2 theta over 2 plus ln 3 plus ln 2 over 2. Ln 4x plus 3, put a common denominator for 2, ln sine 2 theta plus 2 ln 3 plus ln 2. Okay. Ln 4x plus 3. I hope I've not made an error somewhere. I'm just check if my... Okay, I've forgotten to divide by 4 here. Yeah, that's the mistake that I've made. Costly mistake. Okay, so then 2 times 1, 2 times 2. So 2 ln sine 2 theta plus 4 ln 3 plus 2 ln 2. That should also be divided by 4, so there's a problem there as well. Okay, let's do this again from here. So 4 is the common denominator. 2 ln sine 2 theta plus ln 3 plus 2 ln 2. Ln 4x plus 3 over 4. So ln 4x plus 3, and then I combine all of those ln's. So ln sine square 2 theta into 3 into 2 squared. That's ln 12 sine square 2 theta and ln 4x plus 3. So how did I separate the variables? I brought theta terms on one side and x terms on the other side. I cancel out the ln's, so 4x plus 3 equals to 12 sine square 2 theta. 12 sine square 2 theta minus 3, and then 12 sine square 2 theta minus 3 divided by 4. Okay, that's the correct answer. Question number 9. With respect to the origin O, the points A, B, C have position vectors given by this. Find a vector equation for the line through AB. So if you've done vector equation of a line, the formula is A plus lambda B. A can be any point, and if it passes through AB, B, then A and B, then B should be capital AB, which is OB minus OA. I'm going to write that directly and say that it's lambda times OB minus OA is minus 3, 5, and 1. Or use a scalar product to find the exact value of cos BAC. So cos BAC is going to be BA dot BC over magnitude of BA and magnitude of BC. BA is what I just found. You can invert the signs and say that this is BA 3 minus 5 and minus 1. And BC, no, my bad. Wait. Okay. When you're doing this angle, I mistakenly wrote BA and BC. I should write AB and AC. Sorry, my bad. Not one. Okay, so AB is something that I've already found. That's what I thought, that I was doing something wrong. And AC is OC minus OA. So that's 1, 7, and 3. That's a dot product. Three square, 5 square, 1 square, 1 square, 7 square, 3 square. So minus 3 plus 35 plus 3 over root of 35 and 59. The cos BAC is then all of this. That's the exact value of cos BAC. Okay. I don't know if my calculator is going to simplify something out of this, but because I see 35 is common, so it can be reduced. The calculator is not showing a decimal, so that's or exact simplified equivalent. This one is also fine. There's another form of the equation that I can show you, but that's also fine. Okay, then it says hence find the exact area of triangle ABC. I'm going to use the formula half AB sine C. Since I have the sides AB and AC, and I also have the cos of this angle, okay, so I'm going to say that area is going to be half. The length of AB was root of 35, then root of 39, root of 59, and then I want sine of theta. Okay, now I will have to convert my cos theta, which is 35 over root 35 root 59. I will have to convert that into sine theta. So sine square theta plus cos square theta equals to 1. So it's 35 squared over 35 into 59. So that's 35 over 59. That's cos square theta. Okay. So 1 minus answer. 29 square theta is then 24 over 59. So sine theta is going to be root of 24 over root of 59. That makes my calculation very easy actually. I can cancel out this, the root of 35 into root of 24. 35, 24. 840, half of root 840 is what area is. Okay, I can leave it like that, I think. Or I can factor out something. Yeah, that is also fine, but I can so yeah, add something common and say that this is going to be 2 root 210. Root 210. Okay, that was question number 9. We are on to question number 10 now. Okay. Okay, find the quotient when x squared is divided by 1 plus 4x squared. So that's unusual. Okay, so I am going to multiply with this with 1 over 4 so that I get x squared then. Okay, and I'm going to get a complementary 1 over 4 with it. So change the signs and say that this is minus 1 over 4. So the quotient is 1 over 4 and the remainder is minus 1 over 4. Okay. This is find the exact value of this. So I have to integrate this. How many questions remaining? I think there are 2 questions remaining. Okay, let's quickly do this. So this is integration by parts. I write I late first. So u is x. V dash is tan inverse of 2x. Sorry, my bad. I can't do that. U is tan inverse of x. And v dash is x. So v is x squared over 2. And u dash is 1 over 1 plus 2x squared into 2. So vu minus integration of vu dash. Vu x squared over 2 and 2 over 1 tan inverse of 2x minus x squared over 2 into 2 times 1 over 1 plus 4x squared. So if you notice now, this is an improper fraction. For improper fractions, you have to separate the constant first. If you're doing it that way, then that's also fine. You can end up with partial fractions that way. But you see, when these questions, ask you to divide this in this format, they are actually expecting you to use this. You see, this is exactly what you've done here. You've divided x squared with 1 plus squared. How do you write this remainder and quotient? Remember writing mixed numbers when you had, let's say, you divide 23 by 5, so you get 5 times 4 is 20, then you write 4 whole number 3 over 5. You can do that with algebra as well. So I can write the quotient, which is the whole number. The only thing that I have to do is, after I've written the whole number, I write a plus sign, and then I write the remainder over the divisor. That's what I do. That's how you write algebra in mixed fractions. So this is technically equivalent to what I was trying to integrate here. Okay, so I get 1 over 4 plus minus 1 over 4 and 1 plus 4x squared. Okay, so that is x, and that one is again tan inverse. We get minus x plus 1 over 4, and with tan inverse I'm going to say it's half tan inverse of 2x. Okay, that's also very visible from the earlier working, and I had x squared over 2 tan inverse of 2x. Okay, what are my limits? My limits are 0.5 and 0. I need to remember to put it in radians. 0.5 and 0. So 0.5 squared over 2 tan inverse of 2 into 0.5 is 1. 0.5. Okay, there was a 1 over 4 with it. I don't know why I got rid of that. 1 over 4x. Hmm, 0.5 over 4 plus 1 over 8 tan inverse of 1. This one becomes 0 because x squared will make everything 0. Then another 0, and then another 1 over 8 tan inverse of 0. So that's 1 over 8 into pi over 4 minus 0.5 over 4 is again 1 over 8. And that's 1 over 8 into pi over 4. So this is all 0. So that's 2 pi over 32 minus 1 over 8. That's pi over 16 minus 1 over 8. Okay, slightly tough question, but that is what it is. Let's look at question number 11. That's the last question for today. The diagram shows the graph of this and its maximum point m. Find the exact point of m. So use 5 sine 2x. I'm going to do the product rule. So u dash is 5 cos 2x into 2. And v is power comes down and then differential of the bracket. So dy by dx is then u dash v plus v dash u minus the 0 what's common. I see a cos x common and a 10 common as well. Okay, so either this equals to 0 or that equals to 0. Okay, I see the identity cos a plus b here. So it's going to become cos 2x plus x. That gives me cos 3x. When is cos 0? It's 0 in all four quadrants. So 1, 2, 3, 4. So quadrant 1, alpha is equals to cos inverse 0 is pi over 2. So I'm just going to take quadrant 1. Why? Because it's the first turning point that I want to see. Quadrant 1 is then 3x equals to pi over 2. X equals to pi over 6. Was that the question? It says x correct x coordinate of m. I found that. That should be my final answer. Let's verify total marking scheme. Yeah. Okay, by using the substitution this, find the area of the shaded region bounded by the curve, the x-axis, between x0 and x pi over 4, and the line x equals to pi over 4. Okay, so you first write it out. I sine 2x cos square x dx, and you integrate from 0 to pi over 4. And u is cos x. So you do the immediate substitution first. You write u squared dx by sine 2x. Then you try to replace dx by differentiating your substitution, and you get du over minus sine x. Surprisingly, nothing happens here, so you end up applying the identity for sine 2x, and that's 2 sine x cos x. That helps you cancel out a little. So that cancels out, and again you can replace cos x with u, so that becomes 10u into u squared du over the minus sign, minus 1 basically. You can pull out the minus 1 outside and say this is, you can pull out the 10 minus 10 outside and you say this is u cubed. The u cubed integrates to what? U power 4 over 4. Now I can easily replace u again with cos x, so power 4 over 4. What are the limits? 0 and pi over 4, 0 and pi over 4. So minus 10, do I have to give you an exact value? And the area of the shaded region. So I can give you a decimal as well. That shouldn't be a problem. Let's say anything. Okay, it says the decimal is acceptable as well. That's what probably I'll end up doing. That's cos pi over 4 power 4 over 4 minus cos of 0 power 4 over 4. Everything on my calculator. Cos of pi over 4 power 4 divided by 4 minus, that's going to be minus 1 over 4 into minus 10. It's giving me 15 over 8, which is 1.875. Okay, that is the end of this exam. I have about an hour to spare after this. So what I will do in that hour is go back, check all my answers. The silly mistakes that I've made would be figured out at the end of the exam as well. You should know how to check your exams. There's an entire video that helps you figure out things from a calculator. Please make sure that you watch that and then do that on the exam as well. Thank you for watching.